Hey everyone, Mr. Skelton here, back at it for lesson 3 in unit 5, and we're going to jump right into it. Today we are going to prove two triangles are similar. Now you may hear that and start panicking thinking we're going to have to do proofs. We are not. I am, however, today going to provide you with some quote-unquote shortcuts to show that two triangles are similar. Before today, all we've done to show that two things, when I say things I mean polygons or triangles, all we've done to show that two objects are similar is, one, show that all corresponding angles are congruent and all corresponding sides are proportional. Yeah, we're out of space, okay? So that's basically 6 things that you would have to show. And so today I'm going to give you some shortcuts to show that triangles are similar. So here we go. There are 3 ways to prove that triangles are similar. The first one is called angle-angle similarity, and it looks like this. It's really, really important when you do your homework or do problems, when you make a similarity statement, that you write the little squiggly line there so that I know that you're talking about similarity. That symbol, remember, means similarity. And so here's what angle-angle similarity states. If two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So that is a shortcut, because you don't need to show all of this stuff. You just need to show that two angles from one are congruent to two angles of the other. Okay? So here's an example. Here's two triangles. Obviously they're different sizes. How do we know the triangles are similar? We know that they're similar because angle T is congruent to angle P, and angle R is congruent to angle L. They're in corresponding parts, or they're in corresponding fashion and location, so they're similar by angle-angle similarity. Okay? Method number 2, let me move up here. Method number 2 is called side-angle-side similarity. That should be pretty familiar to you. If two sides of one triangle are proportional to two sides of another triangle, and the included angles are congruent, then the triangles are similar. Okay? Now, I showed you an example here, or below, or right to the left here. You see why two triangles are not. I'm going to show you why they're not. Okay? So obviously it's set up for, side angle side. So we're going to compare 3/6. Now if I'm going small triangle to large triangle, I need to go, I'll put a box around this one, small triangle over large triangle. Now what's the problem with that? Well, if you reduce 3/6, right, you get 1/2. If you reduce 4/10, you get 2/5. What's the problem with that? They're obviously not equal to each other. So that's why they're not similar, because if you're going to say side angle side similarity, the sides need to be proportional, which means they have to be equal fractions, which they're not. Okay? So method 3, side-side-side similarity, and this is the last one. This is all we have. Some students will think that there are more shortcuts. There's only 3, so I don't want you to start making stuff up. We'll do a little review at the end to review the 3, but there's only 3. Side, side, side is pretty basic. If all of the sides of a triangle are proportional to the corresponding sides of another triangle, then they are similar. Okay? So it says, for this example, show that the sides are or are not proportional. So this is a good example because it shows you some different things. And these triangles look pretty close in size. So let's look, sometimes we'll look at this, and instead of trying to flip and move, just look at the side lengths. Like that's the shortest, 2, then 3, then 4. So what's the shortest here? 3, then 4, then 6. So you want to match up. I'll use shapes again. Triangles over my shortest ones. So again, I'm going to go 2/3. And I could have easily went 3/2. And I'm going to see if all these are equal. So 2 is the smallest. My next smallest is 3. My next smallest over here is 4.5. And then I'll use a circle for my 4 and a circle for my 6. Okay? Now, 2/3 is already reduced. 4, 6, I divide those by 2 each and I get 2/3. So this 3 over 4.5, a lot of students are going to say, no, Mr. Skelton, they're not proportional. But if you take out your calculator, okay, if you take out your calculator and hit 2 divided by 3, it's 0.6 repeating. Let's look at 3. Let's do this right here in our calculator. 3 divided by 4.5. What do you notice? It's the same decimal. So I know they don't look the same, but if you get a situation like this, always test it, because it works. So we would say, yes, these two triangles, we would say triangle ABC is similar. I don't have enough space. Triangle ABC, let's see, ABC, I went short, so I'd have to call it FED. There's my little similarity symbol in the middle, and they are proportional. Here's a bonus question. What's the similarity ratio between these two triangles? What's the similarity ratio, if I asked you that? The similarity ratio is the fraction. Remember, ratio is a fraction that they all reduce to. You would say 2/3. Okay? Let's flip it over on the back. Let's apply some of these to some problems. Okay? Lined up here. At the top, you must prove triangles are similar before you can find a missing side, or sorry, missing angle, or set up a proportion. Okay? To find the missing side. So, in other words, what that's saying is, you have to look at these triangles and say, are they similar, yes or no, then find whatever they're trying to find, okay? You must, let me get my highlighter here, you must show or prove that the triangles are similar first, all right? So let's take a look at this first example. Let's first determine if these are similar, and if they are similar, how would they be similar, okay? So when you look at this, would these two triangles be similar? Well, let's take a look. I have this 10, I have 20, and I have 15, and I have 8. It says find the length of ST, if possible. Now when you look at this one, I know a lot of students are going to want to put an X right here to try to find ST first, but you don't know if these are triangles. This is not possible, okay? Now you may be wondering, well, how did you know that? Well, there's only 3 similarity statements. Those are the only 3. Let's go through the checklist. Angle, angle. Do you have on these pictures 2 angles congruent to each other? 2 from this triangle equals 2 from this triangle. No, you just have 1 and 1. Side, angle, side. Now look at this big triangle here. Side, angle, side. Side, angle, nothing. So that doesn't work. And yes, again, you can't find X. You can't assume that they're similar to find X. Side, side, side is all 3 sides. 1, 2, we're missing a side here. 1, 2, we're missing a side. That's why this one is not possible. You have to prove that they're similar first before you can find missing values, okay? Jump over to this one here. Now, again, on these pictures, you may be able to flip them and rotate them and move them and redraw them to show similarity. So if I took this picture here, this diagram, and I kind of took my fingers, pulled this congruent angle and swooped it around, it'll match up. Now, here's what's cool about this one. How are these triangles similar to each other? Well, those are vertical angles, right? They are. So I have angle equal to an angle, second angle equal to a second angle. These two triangles are similar by angle, angle. Now let's go find X. So we want to set up a proportion because we have sides. So what matches up with 14? 14, if you try to swing this around, 14 would match up with 24 because that's the bottom of this triangle, bottom of that triangle. If I go small over big, I have to go small over big, which is 22. And now we're going to use our calculator and do some cross multiplying. So 24 times x is 24x. 22 times 14 is 308. 308 divided by 24 is 12.83. Okay? Questions on that? Should be pretty good. Can't ask questions because it's a video. Silly. All right, let's go to the next one here. Find the length of MP if possible. Now this is a tough one here. Again, you have to first prove that the two triangles are similar. Now what two triangles are we talking about? We're talking about this one here. Use some colors. And then the big one here. Okay? Now, I'm going to redraw these so you can see this, because this is a tough one to see. But I have 8 and 8 from the smaller one. The bigger triangle in blue, what are the side lengths of the bigger triangle? Don't put 10, because this is 8 and this is 10, so these are 18 apiece. Okay? Now, going back to this picture, because remember, we have to use these right here to say if the triangles are similar. So when you come back over to this problem, here are your choices again: angle, angle, side, angle, side, and side, side, side. We have 27 down here on this one. I just added that in there. There's nothing on this one. It's not side, 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 because this red one only has 2 sides. It's not angle, angle. Excuse me, it's not angle, angle, because I don't see any markings of angle. So the only thing it could be is side, angle, side. Now, it is side, angle, side, and here's why. They both share, in this picture, angle n. So that would be the reflexive property, right? Angle n equals angle n for both. So 8 over 18 equals 8 over 18. Obviously, those two sides, the left side, right side, are proportional with the angle in the middle. So we would say that these two triangles are similar by side, angle, side. Now it says to find the length of MP. I'll put an X right there. So we can just set up a proportion. We can go 8 over 18. If I go small over big, then I need to go small x over big, 27. So 18x equals 27 times 8. That equals 216. Divide that by 18, and I get 12. Okay? Let's take a look at the next one here. Go ahead and hit pause and try it on your own, see if you can do it, and then we'll finish up. All right, it says angle J is 29. I'm just going to write that in there. Okay, 29 degrees. Angle L is 34 degrees. Okay. What is the measure of angle Q? Now, we always have to prove that these are similar first. So let's check that. Remember, here's our 3. Got to do that first. Okay. So before I find angle Q, let's make sure that they're similar. So again, this is one similar to the front. Smallest side of this is 32. So I'm going to go 32 over, what's the smallest side over here? 22. And I'm going to go put a circle around 45. My next smallest would be 30, so 45 over 30. Let's see, I used a circle. And then my largest side on this one is 60. My largest side is 40. So I went large triangle over small triangle, large triangle over small triangle. So large triangle 60 over small triangle 40. Now I need to reduce all these fractions. I need to see, and you can just check them with your calculator, just make them a decimal. 32 divided by 22 equals 1.45. 45 divided by 30, 1.5, and 60 divided by 40 is 1.5. Let me just double check, make sure I did my math right here. 32 over 22, so 32 over 22 is 1.45. So we got a problem here. The problem is that these two triangles are not similar, okay? And so this one is not possible because the sides are not proportional, all right? So that's an issue there. So we would say not possible on this one because the sides are not proportional, okay? If they were, we could easily find angle K, and we could obviously find Q by matching it up, but we can't do it. It's not possible there. Sorry, I put not possible there. And the one we just did is not possible here because the triangles are not similar. Okay, last thing is indirect measurement. So let's talk about indirect measurement. We use indirect measurement to find the heights and lengths of difficult objects. So like this massive geyser that's just exploding through the air. or if you wanted to find the height of a really tall tree, the height of a really tall tree, like you can't physically take your hands and take out a tape measure and do it. It's things that would be really hard to measure by hand, okay? And so we use indirect measurement to do that. There's two forms. We use a mirror, and we use reflections off the, squeeze that in, reflection. We use a mirror, and this is what this situation is. You can't really see it, but there's a mirror right here on the ground, so I'll explain the situation. This is a person right here. He's 6 foot tall, and I'll redraw these triangles for you. And what he does is he puts a mirror on the ground, and he walks backwards till he can see the tip of the geyser. So he's using a reflection or a mirror from that, okay? The other type is using a shadow, and you'll see some of those in your homework, but we're going to do this one, which is a reflection, okay? Now, I want to talk about this angle right here off the mirror. Excuse me. That's called the angle of incident is always equal to the angle of reflection. Okay? I'll kind of explain that here in a second. That's just saying that when he walks back and he looks at the mirror, the angle that's created from the mirror to his eyesight is going to be the same angle from the mirror reflecting to the top of the geyser. So, in other words, if you can see my red marking, those angles are going to be congruent. Okay? Why are these triangles similar? I know this is tough to see, but there's actually a 90-degree mark there, and there's a 90-degree mark there on that triangle. So we have angle similarity. And it says because they're similar, now I can find the height of the geyser, find it to the nearest tenth. What I usually do is just redraw these triangles, so I'm going to do that real quick for you here at the bottom if there's enough space. So basically what you have is the person here. So here's his right triangle. He's 6 feet tall, maybe tough to see that number there. And then it's 7 feet from the mirror. And then the geyser's triangle that is formed is X feet tall and 40.5 feet. Okay, and these are all in feet. So we know that this was 90 degrees. We know that this was 90 degrees. We know the angle of incident is the same as the angle of reflection. And so we just set up the proportions. 6 over X equals 7 over 40.5. Small over big, so we cross multiply, so 7x equals whatever 6 times 40.5 is, and you get 243, so you divide that by 7, and you get 34.7 feet, okay? And that's the top of the geyser. So one thing I want to continue to really drive home to you is that when you're doing these problems like we did up top here, it's really, really important to always make sure that you have stated what the similarity statement is before you start solving for x. Always check to see how the triangles are similar, right? And these are the big three. These are the only shortcuts you have. Those are the big three. You want to check to see how they're similar and then go ahead and find what they're asking you to find, okay? All right, so hopefully lesson 3 goes okay for you. Your homework goes okay. If you have some questions, be happy to help you in class.